Hi Year 6, it's great to be with you again today for this week's maths lesson. Thank you so much to those of you who sent your work in last week. It was just great to see all the hard work you've been doing on your Venn diagrams, your Carroll diagrams, your maths puzzles. Today we're going to be looking at properties of 2D shape, but this time we're going to be looking at angles, properties of angles. So the things that you will need for this lesson, you'll need something to write on and something to write with. You will need a ruler, but if you don't have one, don't worry, just anything that you can draw a straight line with. So you could use a pen and draw a line along the edge of the pen or the edge of a book, anything like that. If you have coloured pens or pencils, they'll come in handy, but they're not essential. And something to trace with. Now, not many of us have tracing paper at home these days, but if you've got any baking parchment in the kitchen, just check with an adult first. Or if not, you could just simply use a tissue and just draw through that. I'll show you how later. So pause the video, go and collect your bits and bobs, and I'll see you back in a minute. Because we're looking at angles today, for our warm-up activity, I would like you to have a look around your house or outside at the front or in your garden at the back and see how many different types of angles you can observe around you. So if I look out of my window, I'll tell you what I can see. I can see the branches in the trees. I can see that some of them meet at an acute angle, less than 90 degrees. Some of them meet at an obtuse angle, greater than 90 degrees but less than 180 degrees. I can see the road sign, where there are 4 right angles of 90 degrees making up the sign. I can see a little boy riding his bike and the spokes in the wheel make lots of acute angles. I can see a man walking and the angle as he's walking, as he takes his stride, is making an acute angle. I can see a car that's just gone past, and I can see that the windows, the shape that they are, have got 2 acute angles and 2 obtuse angles. So go and have a look, see what you can find around the environment in your house and how many different types of angles can you find. When we're measuring angles, we can use a protractor, sometimes called an angle measurer, which helps us to see the size of angles in degrees. However, we can still learn a lot about angles even without a protractor. So we're going to look and see how many right angles we've got around this point here. So, one right angle in this corner, 90 degrees. Another right angle. So, the number of degrees on a straight line is the same as 2 right angles, so that's going to be 90 add 90, which is 180 degrees. And then we can add another one and another one. So we've got 4 lots of 90 or 2 lots of 180, which gives us 360 degrees. So the number of degrees around a midpoint, that means where 2 lines cross, is 360 degrees. We can link this to the number of degrees in a turn around a point. So I'm going to use my little Playmobil king to help us. So if he is starting here and he's facing straight ahead, but he turns 1 right angle here, we know that that is 90 degrees. But it's also a quarter of the way around if he is turning 90 degrees each time. It's 90 degrees, a quarter of a turn to get back to where he started. So a right angle is a quarter of a full turn and it is 90 degrees. If he then turns a further 90 degrees, he's come from facing this way, turned 90 and another 90, he's now made 2 quarters of a turn. We know that 2 quarters is equivalent to a half, so he's made half a turn around, and that's 2 lots of 90 degrees, which is 180 degrees. If he then turns a further quarter turn round, he's now turned 3/4 of the way around, which is the same as 3 right angles. And 3 lots of 90, well 3 9s are 27, so 3 90s are 270 degrees. And finally, if he makes a further 90-degree turn back to where he started, he's made 4 90-degree turns. So that is what we would call a full turn. It's the same as 4/4, and we know that when the numerator and the denominator are the same, it's 1 whole one. So he has made 1 whole turn around that central point, and that's 4 lots of 90, or 4 9s are 36, so 4 90s are 360 degrees. These facts that we've just looked at are used in map reading because they are important when we're looking at compass points. So you can see I've added on here the points north, south, east, west. Remember the way that they go by never eat shredded wheat. That's the way that we remember which way round they go. And so I'm going to give you some questions here. You might want to pause the video after each question, have a think about it and jot your answer down. So, for each one, have a look at this compass point before you answer your question. How many degrees are there between north and south turning clockwise? How many degrees are there between south and east turning anti-clockwise? How many degrees are there between northeast and southwest turning clockwise? If you can't remember what clockwise and anti-clockwise means, go and have a look at a clock somewhere in your house. You'll need an analog clock, not a digital one, so one with hands, and watch which way the hands go around. So the way that the hands go around, that's clockwise, and the opposite, if they were going backwards, would be anti-clockwise. So send those answers in on email. These two pirates, Bob and Jim, are having a bit of an argument over a question that the captain has asked them. They've been asked how many degrees there are between northwest and southwest. Bob says there are 90 degrees between northwest and southwest. Jim says there are 270 degrees between northwest and southwest. What do you think? Here's another challenge for you. If it takes 60 minutes for the minute hand to travel all the way around the clock in 1 hour, how many degrees does the minute hand travel in 7 minutes? And how many degrees does the minute hand travel in 12 minutes? You'll need to think back to the start of the lesson for this one and remind yourself about how many degrees there are in the middle where the midpoint of the clock would be. Now for that challenge, you'll need to think back to the beginning of this lesson. Think about how many degrees were equivalent to a full turn, and a full turn is the minute hand travelling all the way around the clock. And then use that information to help you to complete those questions. And here's one more for you, even more challenging. How many minutes have passed if the minute hand has moved 162 degrees? Pause the video now and have a go at that one. We're now going to use what we know to help us to find missing angles on a straight line. So if we call these two angles A and B, so we're looking at angle A here, we know that the number of degrees on a straight line is 180 degrees. So we can therefore say that angle A plus angle B equals 180 degrees. And in the same way, angle B plus angle A is also equal to 180 degrees. If we look at these two now, something minus A is going to give us B. So 180 degrees, because that's the total of A and B, 180 degrees minus angle A would give us angle B. And likewise, 180 degrees minus angle B would give us angle A. So even though we don't actually know the size of angle A and angle B, we know that the relationship between them means that they will both add to a total of 180 degrees. It's your turn now. Think about the number sentences that I've just written and see if you can write some number sentences for each of these diagrams. Think about the facts we've learned at each stage in this lesson. See how many number sentences you can write. Pause the video now. My turn again. I need to think about which angle facts will help me to calculate the value of missing angle A. So I know that the angles on a straight line together add to 180 degrees. So if I say 180 degrees minus 120 degrees, then that tells me that angle A is worth 60 degrees. Your turn again. Take a look at these. Which angles are already given? How can we use this to calculate the unknown angles? What does this symbol mean? What size angle is that? We're now going to investigate opposite angles, but before we move on, let's just recap on a few things. We've learnt or reminded ourselves that angles on a straight line add to 180 degrees. So A and D would add to 180 degrees. B and C would add to 180 degrees. We also know that the number of degrees around a full turn is 360 degrees. So angle A plus B plus C plus D would equal 360 degrees. And the point in the middle where the lines cross, we're going to call that the vertex. We learnt that word last week when we were looking at 2D shape. A vertex is a corner. So the corner of angle D, the corner of angle B, the corner of angle A, and the corner of angle C all meet at this vertex. Now I want to see what I can find out about the relationship between the angles. I don't have any tracing paper at home, so what I'm going to use is a tissue, because I can just about see, if I press it down, those angles underneath. So I'm going to draw them and cut them out and see what I can find out. So now I'm going to position the bits that I've cut out on top of the angles that they are equal to. Doesn't matter if the triangles aren't quite the same size, it's the angles that we're looking at, that's what's important. Now, as I look at those, I can see that there seems to be a similarity between these two angles, and there seems to be a similarity between these two angles. So what I'm going to do is flip over angle A, place it on top of angle C, and I can see that the angle here is exactly the same. I'm going to do the same with this. I'm going to flip angle B and place it on top of angle D, and I can see that the angle here is exactly the same. So if I take those away, what I can what it looks like is that the angles that are opposite each other are equal in size. So A is the same size as C, and B is the same size as D. Now, what I'd like you to do is investigate that, see if that's the case for angles of other sizes. So what you would need to do is to draw two lines crossing as I've done, and they can cross at any point at all. So you can have a very small angle here and here, or a very small angle here and here. Just experiment, just investigate with a number of different lines crossing. And you could try my idea with the tissues if you haven't got tracing paper at home, or you might have baking paper, baking parchment in the kitchen. Ask a grown-up if you can use that. And just investigate, as I've done here, and see, is it true that angles that are opposite each other are equal in size? Because we'll need that information before we move on to the next part of the lesson. Hopefully you found, as I did, that opposite angles are equal. And we're talking about vertically opposite. That means where they cross at a vertex. So D and B are vertically opposite each other because they are opposite, the vertex is in the middle of them. A and C are vertically opposite because again they are opposite across the vertex. So now we can use that to move on and find the size of missing angles, and we're going to have a look at a range of question types on this. So here's a Chile 1 challenge, and I'm going to take my turn and then I'm going to let you have your turn. So for this one I've got to find missing angle A. Well, I know that vertically opposite angles are equal, so I know that A equals 130 degrees. Nice and easy, that one. Let's have a look at a Chile 2 challenge. And here I've got to find 3 missing angles. Angle C, angle X and angle Y. Now, there might be more than one way that we could do this. So let's make a start and see. Well, I know that vertically opposite angles are equal. So I know that C equals 47 degrees. Just jot that 47 in there. I also know that the total of angles around a midpoint, here's the vertex, the midpoint, that they total 360. So angle C plus angle Y plus 47 degrees plus X comes to 360 degrees. So what I'm going to have to do is find, by what I know here, find angles X and Y. Now I could do it by saying, well, I know that angle 47 degrees plus angle X comes to 180 degrees because angles on a straight line add to 180. In the same way that angle C and angle Y would add to 180 because they're on a straight line. But I think what I'm going to do is use my knowledge of opposite angles to work this out. So I need to work out what 47 add 47 is. Well, if I double 4, that's 8. So double 40, that's 80. Put my jottings over here. Now I need to double the 7. Double 7 is 14. So 80 add 14 is 94. So this angle and this angle comes to 94 degrees. That's 47 degrees plus C equals 94 degrees. Now I've got to use that to help me to work out angles X and Y. Right, all of that is 360 degrees. So I need to take away, subtract the 94 degrees here. So 360 degrees minus 94 degrees. I'm going to think about mental strategies to help me here. I'm going to round 94 to 100, but then I'll need to remember to take 6 off my answer because I've added 6 too many on. So 360 minus 100 would be 260. 260, adjust it by adding the 6, gives me 266 degrees. So angle X plus angle Y in total is 266 degrees. But I've got to find out what X and Y are both, what size they are. I know they're equal because they're vertically opposite angles. So half of 266 is going to be the value of X. Half of 266 is going to be the value of Y. Let's have a look what that's going to be. Half of 266. Okay, So half of 200 is 100. Half of 66 is 33. So that tells me that angle X is 133 and angle Y is 133. Now I can check my working out, because if I am to add together all four angles, it should come to 360. Can you do that for me? Can you check? Does that come to 360? Pause the video. I've checked too. Yes, it does come to 360, so that's great. Okay, let's look at the Chile 3 challenge. And for this one, I'm going to let you have a go. Use the information that you've learnt in the lesson and see if you can work out missing angles A, B, C and D. I'm now going to show you your Chile challenges. So I suggest you look at all of them first, Chile 1, 2 and 3, and then decide which one or which ones you want to do. You might decide to do all of them. And then once you've chosen it, you'll need to pause the video so that you can see your Chile challenge on the screen. Good luck. The Chile 1 challenge is to find the 3 missing angles in each diagram using the strategies that we've looked at in this lesson, and also to label each angle. Is it acute, obtuse, or is it a right angle? So there are 3 diagrams for you. And here's Chile 2. And finally, Chile 3. I'm just going to go in closer so that you can take a look and see the questions that go with it. So choose your Chile challenge and do send your answers in to us. We look forward to hearing from you.